Hi, I'm Adrian Cockcroft. Over the years, I've given a lot of talks on microservices and cloud architectures, and there are some ideas I always wanted to illustrate with a short animated sequence. So I've worked with a visual design team to come up with a series of animations, each illustrating a specific concept. Okay, this is Adrian Cockcroft. This month, I'm going to be talking about safety margins and availability and how to measure availability. Let's start by thinking about what the users need. They need systems to be safe, highly available. They need to make sure they have enough capacity. They need to be durable, not lose data. And there needs to be enough of a margin around these things so that you don't suddenly run out of capacity or run out of availability. Let's take an analogy of driving to the airport to catch a flight, something I do quite often. There's a dynamic capacity here, and there are margins. So I have a car, it has a certain amount of fuel range, it's got a certain stopping distance if I need to do an emergency stop, I need enough space in the lane, I need enough time to get there. But let's be a bit more specific, and let's actually look at the difference between failures and outages. I think this is an important distinction. Let's say my car fails to start, or on the way I get a puncture, I get stuck in traffic, I don't make it to the airport in time. Right? These things tend to happen if you go to the airport often enough. But if the car fails to start, I can always call a taxi. So I have the failure, but I don't have the outage. I have a spare wheel, so I can repair a puncture. But, I'm still probably going to get to my destination late if I have to take the extra time to wait for a taxi to come or change the wheel, or I get stuck in a traffic delay. So the standard policy we have is leave a margin for problems so you can still arrive on time. I tend to try and leave for the airport an hour earlier than I would really need to. And then when I get there on time, I have time for a meal or to chill out for a bit in an airport lounge or something. But, when things go wrong, I get there and I still have time. So let's look at some probabilities and try to understand how these things combine. Look at the probability of getting a puncture in a tire, and I'm just going to make up some numbers and assume that every 4,000 miles, on average, you get a puncture. When you look at the whole car, there are 4 tires, and if you assume that they independently have a chance of getting a puncture, that means they're 4 times more likely to get a puncture. So this is one of the characteristics of complex systems or large systems, is when you have lots of components, they're going to fail more often, assuming they're independent. So what we do is we put a spare tire in the car. And what difference does that make? So let's assume that you use the spare, and then you actually get that spare tire fixed 100 miles later. Right? This matters. If the time that you spent running around with no spare tire, you're exposed to a second problem. So the probability of a puncture while the spare is being used is 1/10, so it's 10 times better. So the total probability of having a problem if you have a spare tire in this scenario is 1 in 10,000 miles instead of 1 in 1,000 miles. So that's why we have spare tires in cars. Hopefully we don't get punctures that often. But you can do this kind of math with all of the different systems and looking at, when you look at the things you have to compensate for the failure. So you're trying to take a failure and avoid having an outage by having spare capacity. But in the real world, it's never that simple. Turns out your spare tire is probably flat. You can't get the wheel nuts off. It's too hard to change the tire. And often punctures are correlated because you run over something and it punctures more than one tire at once. So in the real world, things are much more messy and complicated, and you have to take that into account as well. So quite often what people do nowadays, you don't have a spare tire. They're heavy, they don't get needed that often, but they put cans of Fix-A-Flat in there. They're cheaper, smaller, easier to use, but they don't solve all problems. And the other thing is that mobile phones now provide an additional way to get out of this problem by calling for help and getting somebody to come and tow you to where you need to be. So think about the more complex thing. Don't just look at the simple availability calculation. So that's how to think about failures and outages, but how do we actually measure and report these kinds of outages? And there's 2 ways of thinking about it. One is to measure availability over time, which is sort of the traditional way of thinking about it. The other way is to think about successful operations. If you have a monolithic system, and anything goes wrong, and it'll go down. So if we think about that, here's a system, it's got some traffic, it's running through a 24-hour day, it gets busy at lunchtime, gets quiet at night. It's a very common kind of graph that you might see. Let's say somebody forgot to renew a certificate, one of the security certificates, it expired, and took you 6 hours to figure out how to make a new security certificate and fix it. So the availability here, what is that? And we can measure it in a bunch of different ways. But it really matters what time span you're measuring across, because during the outage, the availability is 0, and the rest of the time, the availability is 1 or 100%. So if you look at your availability on a daily basis, this is a 75% availability. But quite often, we tend to average over longer periods. So let's say it's the only failure we get. The availability for a week is now 96%. So that starts to look a bit better. We're used to hearing about how many 9s you have for these kinds of things. So if you roll up all your availability to a month and manage to only have this one failure, you've now reached 99% availability. If somebody's telling you they need 2 9s or 3 9s, you have to ask them also, over what time period? Are you measuring this over a week or a month or a year? Because one outage can take you out, but it really matters. The time span that you're measuring over actually affects what you're going to see. Like if you look at a whole year, this is a 3-9 system, if you can make sure that this is the only time you forgot to renew your security certificate. But this is just up and down. It doesn't tell you about the success rate, because if you look at the number of successes versus the number of failures for this day, it depends on the time of day. If you have an outage during peak time, then it's going to be more impactful than you have the same duration outage at night when the traffic is lower. So I didn't do the actual calculation in these areas, but it's definitely not 75%. So this leads to a more sophisticated look at availability, because it turns out customers care more about success than availability. They care about every time they try to do something, did it work, rather than, maybe the system was down when they weren't even trying to use it. So success is a developer and business-oriented metric, and availability tends to be an operations and infrastructure-oriented metric. And as we get more towards business-driven DevOps, I think it's important to use success rate, not time, to drive availability. And if we look at a system that's a more sophisticated system, in this case, we didn't get a complete outage. We had something go wrong which affected one service, say in a microservice, or it caused some percentage errors. And what we have, you can see where the issue starts. We seem to have lost a bit of traffic, and then the issue ends. So we now need to come up with an estimate of what it should have been versus what was expected. So if we can come up with an algorithm which says, well, this is the shape of the graph that I'd expect it to see, then I can measure just this red area is the missing data. This is places where I got errors and I didn't get success. And I can take this success rate. I mean, availability over time was perfect. We never actually had a 100% outage, but we did have failure to serve customers. So we need to take the green area, divide it by the red area, and this gives you a much more sensitive request-weighted availability, which in this case, it's a few percent failure rate, but you tend to find every day there's a couple of glitches. It takes advantage of the predictability of the workload for common workloads that are very smooth looking if you average together a large number of users, particularly for consumer-facing websites. You can get a pretty good idea of what you should have been seeing, and you can figure out what traffic didn't arrive at your system. I hope you found that interesting. Please let me know what you think via comments or Twitter @AdrianCO, and stay tuned for new stories. Thanks for watching.